Hey guys, this is Mr. Grice for Algebra Unit 8.2 Notes. Today we're talking about identifying solutions of a quadratic equation from a graph. Our learning target today is to be able to identify the solutions and other important parts of a parabola from a graph. Now, I know you guys are all anxious about writing down that definition, but don't worry, we're going to go right back to it. Now, I want to go to the problem. Y equals x squared plus 5x plus 6. So I want you to imagine this equation. You don't have to write this down. We're just going to talk about it. Now, if we want to know how many x-intercepts it has, we would say that the x-intercepts equal something and kind of solve and plug in to figure that out. So the real x-intercepts for this equation would be -3, 0 and -2, 0. So these numbers mean something. Now on the graph, what they mean is where they intersect. Sorry guys, this is just a real quick one at -2, 0 and -3, 0. So those are the points right there. And is this graph, would it be going up or would it be going down? Which way is it facing? Remember, we can tell by looking at the leading coefficient, and the leading coefficient is positive, which means our graph is positive. Now, I don't know if this is an accurate representation of everything about that graph, but it's something similar to that. Okay. But another way that we would do it is instead of y, if it was a 0. And now you're actually solving to find the x-intercepts. And when you're solving to find something, you would say that, oh, x equals -2 or -3. So you see how there's just a slight difference in how we write our final answers there? So today what we're going to be talking about is, once again, we're going through all the different parts of the graph. And today we're talking about solutions of a quadratic equation, okay? And the solutions are the x-intercepts of the parabola, and they're written as x equals the number, okay? I'll leave that definition up there. And so two real solutions has two intercepts. And there can be millions of different ways that you draw this, guys, millions and millions, okay? You can say that it looks like this, it could be facing down. It could be facing up, it can be wide, it can be skinny, it can be either one of those, okay? But it has to cross the x-axis 2 times. Now, one real solution means that the parabola has one intercept. So if it has one intercept, it could look like this. It could also look like that. Let me show you what it can't look like. It cannot look like this. Like, well, Mr. Grice, this line, it doesn't continue. It stops right here. Well, yeah, but you drew an arrow, and the arrow means that it keeps going. So technically, that does have two solutions. Okay? And then our last one, no real solution, has no intercepts. Now be careful how you draw this one. Because if you draw it down up here, you're like, hey, look, it has no intercepts again. No, guys, this actually would have intercepts because the lines keep going. Okay? Once again, you can have tons of different pictures for this. It can be any of that. It could look like that. It could look like this. As long as your graph does not touch the x-axis, you're fine. It can be any of those pictures. Okay? All right. Now, let's identify the specific parts of each parabola. Let's look at number 1. What is our vertex? Remember, the vertex is the highest or the lowest point. And for here, it is -1, -4. Now our axis of symmetry, remember that we steal the x from the vertex. The axis of symmetry is the line that cuts it in half. And that means our axis of symmetry is an equation, and it's x equals -1. Now our y-intercept is where it crosses the y-axis, and that point is 0, -3. And then our x-intercepts is where it crosses the x-axis. And remember, and for this one, it doesn't even say x-intercepts. I misspoke. It's the solutions. So our solutions are x equals, this point's -3, 0, so -3. And that's 1, 0, so our solution would be 1. Why don't you guys try number 2? Go ahead and pause the video, and good luck. Okay, so the vertex for number 2 is 3, 0. The axis of symmetry is x equals 3. The y-intercept was hiding. It was all the way up there at 0, 3. And this only has one solution, and that's at 3, 0. All right, last one, number 3. Let's do it together. Our vertex, that is the point -1, +4. Remember, the axis of symmetry is that line that goes through the vertex. It cuts the graph in half. X equals -1. Our y-intercept is where it crosses the y-axis, and that's the point 0, 5. And our solution, does it ever cross the x-axis? Nope. So for this one, there are none. All right, let's move on down. So, graph the parabola that fits the description if possible. So, we need to, first off, draw a graph. So the vertex is at the point -2, -1. It has 2 real solutions, and it opens up. So if it opens up, that means it has 2 solutions. It's got to cross the graph at 2 points and opens up. Are we able to do that? Yeah. So what we would say for this is possible. It is possible to draw that. And that should be a B. Now, let's look at the next one. Once again, we're going to draw a graph. Okay, my vertex is at the point 3, 4, so there's +3. It goes down, and it has one solution. So I can only have it touch the graph once. Does that work? Can't do that. Can't even try to cheat and do that. This is not possible. You can't have a quadratic that looks like that. Okay? All right, let's go ahead and flip it over. Now, on to the good stuff. Application. Why don't you guys take a second and read number 6. Go ahead and highlight, read, underline, circle some keywords for me, okay? So the first thing I noticed was that X represents the time. So that's on the bottom. So I'm going to fill in the rest of it. So 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is the time in seconds. What about the Y? The Y represents the height, and that is in feet. What are they counting by on the y-axis? They started with 2, so that means we're counting by 2's. All right, so this says during baseball practice, Mario threw the ball as high as he could. The graph shows the trajectory of the baseball. In the graph, X represents the time that passed after he threw the baseball in seconds, and Y represents the height of the baseball from the ground in feet. So, what is the baseball's maximum height? Well, the maximum height is the highest point of the graph, and that is right there. So that is 18, and that's 18 feet. Now, if you notice, that's the highest point. Guess what that is? That's the vertex, guys, but they don't ask you, what's the vertex? Okay, they want to know the maximum height. So that's how that's used in a real world question. The next one, it says, how long did it take the baseball to reach its maximum height? Well, let's count down. Ooh, how many seconds is that? Well, do we know for sure? Well, we had to approximate, right? And when we have to approximate, we have to put the little squigglies that's saying we're rounding our number, and that is approximately 3.5 seconds. Well, you know what that sure looks like? That sure looks like the axis of symmetry to me, right? Yeah. And then the last one is, how long did it take the baseball to hit the ground once Mario threw it? Now, if you notice, first off, the starting height, why wasn't this started at 0? Well, because he's throwing the ball, right? So if Mario, I'm going to draw Mario real quick. Mario's a boy, so he's going to be in blue. If Mario is throwing a ball, you throw a ball standing up. You don't throw a ball lying down. So if you're lying down, you can't throw it very high. Just imagine lying on your back and trying to throw a baseball. It'd be pretty tough. But if you're standing up, you would throw it at the highest point that your arm reaches. Okay? So then when he throws this ball, he throws it up here and it goes, and then it hits the ground. And where does it end up hitting the ground? How long did that take? Well, I'd say that took about 7.5 seconds. Okay? And is this graph opening up or opening down? It's down. That's right. All right, let's go ahead and look at the next one. Why don't you guys pause the video and see if you can answer all these questions on your own? Good luck. Okay, there are the answers that I got. Now, we're talking about a toy rocket. So the toy rocket normally gets shot off on the ground. And so it's all the way down here. And then the height is at the very top. And once again, that is our vertex, okay? And the vertex, once we go all the way down, we will find that the seconds it took it to get there was 4. And then the last one, how long did it take to hit the ground? Well, it didn't hit, nope, it's still up in the air. Oh, but now it's coming down, it's closer, it's closer, it's closer. Boom, hits the ground. Now, it's not at 7, it's not at 8, it's closer to 8 than 7, so around 7.8. And I do the squiggly marks because I rounded that answer. Okay? Well, guys, that's it for Algebra 2, or Algebra 1, 8.2 notes. Your homework is the 8.2 practice, where you're going to be answering some of the same questions, okay? If you need help, please come find Ms. Carranza or myself. We would love to help you out. Otherwise, this is Mr. Grice signing off for Algebra Unit 8.2 Notes. Thanks for watching.